Dear students, I welcome you all for the chemistry class that is on the date of 14th December. Now let us revise the concept of the periodic classification, that is our chapter number 5. So let's look at the concept. Let us first study about the matter around us is present in three forms. One is element, another is compound, third one is mixture. Elements contain atoms of only one type. Elements known till date are 118. Out of those 118 elements, my dear students, 98 elements are naturally occurring, whereas 20 elements are man-made elements. So this is what we have the great number of elements present with us for study. Why elements are needed to be classified? So why do we need to classify these elements? Many elements are discovered, and scientists have gathered more information about them and their properties. Due to vast or huge amount of information about elements, it started difficult to study these elements. These elements were very difficult to be studied because their number was huge and new elements have been discovered. So the about it started the information. It started the need to organize the information or the information about element in organized manner. So there was a need to study the information of about elements in an organized manner and to study the large number of elements and their properties in an organized manner, elements are needed to be classified. So this is what it was the major reason that to study the elements in an organized manner, there was a need of classification of elements. Scientists started looking for some patterns in the properties of elements. So scientists have started looking for some patterns in the properties of elements. Now let's move forward and let us understand how they have started arranging the elements, that is, making order out of chaos. To study various elements in the organized manner, scientists were looking for some similarities in the properties of elements. They wanted to make an order out of chaos as the following example. Now, my dear students, when you go to the grocery shop, you will find that the grains are separated from the soaps. Even the soaps are classified into shampoos, the bathing soap, and the washing soaps. And then, according to the various company, like these soaps and detergents are arranged. So, if we go to the grocery shop, we find grains are separated from soaps. Soaps are also arranged in the collection of bathing soap, washing soap, liquid soap, even each soap category arranged according to their brands. So this way, even if you go to the grocery shop, you will find the arrangement in an organized manner. Same way, scientists were looking for some patterns so that they can make an orderly arrangement from chaos. In the first attempt, elements were classified in two classes, metals and non-metals. So you may be asked that what were the first two classes in which the elements are classified? So elements were first classified in two classes. One was metal and another was non-metals. Now, my dear students, we want to study about the Doberainer triad. Doberainer arranged elements into the increasing order of their atomic mass. Doberainer found some group of three elements such that the atomic mass, please remember this is the basic idea for the Doberainer triads. He found the group of three elements such that the atomic mass of second element is roughly the mean or the average of atomic mass of the other two elements. Doberainer called them as a triad. Triad means group of three elements. Now, whatever we have studied, let us look at it as an example. So, let's understand the Dobreiner's triad by looking into the example of it. Let's have a look at it. You can see here we have the examples of Dobreiner's triad. Examples of Dobreiner's triad. You can see here. First, we have triad, then we will look into some other points like um, so the first triad is lithium, sodium and potassium. The triad number 1 is lithium, sodium and potassium. The atomic mass of lithium is 7, the atomic mass of sodium is 23 and atomic mass of potassium is 39. So the atomic mass of sodium, that is Na, atomic mass of sodium is equal to roughly the average of the first and the second element, that is what we consider it. So when it comes to this, my dear students, we come to know that 7 plus 39 divided by 2. This is how we take an average, or this is how we take the mean of the mass of these two. So we add this both 2 and then we divide it with 2. So by adding we get 46 divided by 2, we get 23, and exactly this 23 is the atomic mass of sodium. And this is how, my dear students, the Dobreiner has started the triads. So you can see that the mass of sodium, the atomic mass of sodium is exactly the mean of the atomic masses of the lithium and potassium. Same way, if you look at the triad number 2, which is made up of chlorine, bromine and iodine. So atomic mass of the middle element, which is known as the bromine, this element, atomic mass of the second element is the mean of the atomic mass of the first element and third element. So we take 35.5 plus 127 divided by 2, which is roughly 81.25, and this 81.25 is very near to the 80, and that is what we can say it is roughly the atomic mass of the second element. The third triad, which our Dobreiner discovered, was made up of the calcium, strontium and barium. So the mass of the strontium is found 88. Now we can calculate it that atomic mass of strontium is the mean of these two atomic masses. So we take 137 plus 40 divided by 2, which is 177 by 2, which is roughly equal to 88 only, because it is 88.5. So this is how, my dear students, Dobreiner find out these triads, and he said that the atomic mass of the second element is roughly the atomic mass of the first element and the third element. Now, my dear students, we want to study about the limitations of the Dobreiner's classification. So let's look at various limitations of the Dobreiner's classification. Please pay attention. We are going to study about the limitations of the Dobreiner's classification. Let's look first, the first limitations of the Dobreiner's classification. Let's look at the first limitation. The average atomic mass of first and the third element was not exactly to the atomic mass of second element. It was not exact. It was roughly the idea, but it was not exact. What is the second limitation? Classification of Dobreiner was not applicable to all the elements. Classification of Dobreiner was not applicable to the all the elements. It was applicable to very few elements. And there was the third limitation, that Dobreiner could find only 3 triads. So only 3 triads were found. That is why this Dobreiner's classification was not very useful, or it was not applicable, but still it has given some pattern for the study of the elements. Now, my dear students, we want to study about the Newland's law of octaves. Newland's law of octaves, or we want to study about the Newland's classification. So let us study about them. Work of Dobreiner has encouraged an English scientist, John Newland, to correlate properties of elements with the atomic masses. So, my dear students, the work of Doberainer encouraged a new scientist, John Newland, to arrange the elements in a classical manner. At that time, means at the time when the John Newland have started the classification, at that time, 56 elements were known. Newland arranged all these elements from atomic mass number 1 hydrogen to the thorium. So this, whatever the elements they were available at that time, he has arranged all the elements. So hydrogen was also available, and the last element which was having the highest atomic mass was available, which was thorium. And total 56 elements were available for the arrangement at that time. Newland observed that every eighth element has the property similar to the first element. Now, this was the basis on which the Newland has uh, arranged all these elements at that time. First of all, he has arranged all these elements in the increasing order of their atomic mass, and he found that the first element was similar to the eighth element, same as the musical notes like sa, re, ga, ma, pa, dha, ni. Again it comes sa. So the first sa and the eighth sa, they are same. You can even count sa, re, ga, ma, pa, the ni is 7, and then eighth one comes, that is sa again. The same thing he observed that, Newland observed that every eighth element was similar to, has the property similar to the first element, as good as the musical notes like sa re ga ma pa dha ni sa. Again sa comes. So for example, sodium was the eighth element after lithium. Both lithium and sodium have the same properties. This is how the Doberainer found that the element named lithium has very similar property with the sodium, and if we count, then sodium and lithium are the elements which have the same, which have the lithium is the first element and sodium is the eighth element. Similarly, beryllium and magnesium resembles each other. Similarly, this beryllium and magnesium also resembles each other. So beryllium is the first element and magnesium is the seventh element. This is how we understand. So Newland's law of octave. Now let us study the law of octave. Like musical notes, sa re ga ma pa dha ni sa, and sa re ga ma pa dha ni sa. Again the sa comes at eighth position. We can easily know that the first sa and the eighth sa are similar. Same way, if you look into the Western musical notes, do, re, mi, fa, so, la, ti, and again do. This first do and the eighth do are same. This is the way we understand about the Newland's law of octave, and Newland says that like the musical notes, sa re ga ma pa dha ni, and again eighth comes sa, or the Western way do re mi fa sa no, do re mi fa so la ti. The next eighth is similar. Even Newland found that every eighth element has properties similar to the first element. We have seen the example of lithium and sodium. We have seen the example of beryllium and magnesium. That lithium, if we consider it as a first element, sodium is the eighth. Beryllium, if we consider as a first element, magnesium is the eighth. And according to the Newland's law of octave, it says that every eighth element has properties similar to the first element. This statement is called the Newland's law of octave. Which is the statement called the Newland's law of octave? Every eighth element has the properties similar to the first element. This is what it is known as the Newland's law of octave. So Newland has arranged all these elements and gave the Newland's law of octave. What were the limitations of the Newland's law of octave? So it was found that the law of octave was applicable only up to calcium, and after calcium every eighth element did not possess the properties similar to that of the first. It was found that the law of octave was applicable only up to calcium, and after calcium, every eighth element does not possess the property similar to the first element. Thus, Newland's law of octave worked only well together for the lighter elements only. So this is the first limitation, that Newland's law of octave was applicable up to first 20 elements or lighter elements. Then after 20 elements, it does not actually work. It was assumed by Newland that only 56 elements existed in nature and no more elements will be discovered in future. But later on, several new elements were discovered whose properties did not fit into the law of octave. The third limitation, in order to fit elements into his table, Newland put cobalt and nickel into the same slot. Remember, he put cobalt and nickel into the same slot, and these are placed in the same column as fluorine, chlorine, and bromine. Now, cobalt and nickel, they are not similar to the chlorine, fluorine, and bromine, which have very different properties than these elements. But iron, which resembles to the cobalt and nickel in properties, has been placed far away from the cobalt and nickel. So this is the third limitation of Newland's law of octave, that Newland arranged these elements in such a order, in such a way that these elements have not proper properties. These elements are not arranged in the in the manner as such that they resembles with each other. The improper elements are placed in the same group, whereas the element which have same properties, they are placed apart during this process. So this is how, my dear students, we understand the three limitations of the Newland's law of octave. Once again, let me revise it. The first limitation was that it was applicable up to first 20 elements or the lighter elements. Second, he thought that only 56 elements exist in nature. No more element will be discovered, but new element discovered. And these elements which were discovered later never followed the Newland's law of octave. And in setting up the table, Newland made mistake by arranging the different property elements like cobalt and nickel with chlorine, fluorine, and bromine, whereas the very similar element iron was put far away from the cobalt and nickel. Now, my dear students, we want to study about few more things, that we want to study about the Mandeleev's periodic table. You can see here the picture of a very great scientist. This is the picture of the scientist Dmitry Ivanovich Mandeleev. So here we have the Dmitry Ivanovich Mandeleev. This scientist has discovered the uh, the periodic table, and he is considered as the father of the periodic table because his work was considered to be the most important work for the development of the periodic table. So now we are going to study about the periodic table which was given by the great scientist Ivanovich Mendeleev or Dmitry Ivanovich Mendeleev. The main credit of classifying element goes to the Russian scientist Dmitry Ivanovich Mendeleev. This Dmitry Ivanovich Mendeleev has classified the elements in a different manner. Mendeleev classified elements on the basis of their fundamental properties, increasing atomic mass, and similarity of chemical properties. Suppose you are asked in the example that on what basis Mendeleev classified the elements. The answer is simple, that Mendeleev classified the elements on the basis of their fundamental properties, increasing atomic mass, and similarity into the chemical properties. Now, my dear students, we want to study some of the, when Mendeleev started his work, there were 63 elements known at that time. Now we want to study how Mandeleev has studied these elements in detail and how he has developed his own periodic table, which is known as the Mandeleev periodic table. That is what we are going to study into the next point. Let's pay attention. How did he develop the periodic table, which is called the Mendeleev's periodic table? Mendeleev examined the relationship between the atomic masses of the element and their physical and chemical properties. So the first thing what he did is to correlate the masses and the physical properties. Among chemical properties, Mendeleev concentrated on the compound formed by the elements with oxygen and hydrogen. He selected hydrogen and oxygen as they are very reactive and formed compound with most of the elements. The formula of their hydrides and oxide formed by an element were treated as one of the bases or basic property of an element for its classification. So my dear students, when Mendeleev started the classification of elements, there were 63 elements present at that time. What did he do? He allowed all these elements to react with the hydrogen and to react with the oxygen. So when all these 63 elements reacts with hydrogen and oxygen, they form their hydride with hydrogen and they form their oxide with oxygen. Then he formulated the chemical formula of those compounds which was produced by those 63 elements when they react with the hydrogen and oxygen. And those elements which have same kind of formula, he placed these elements in the same group. And this is how he classified the element by keeping in mind the formulas of their hydrides and oxide in its mind. Then next what he did do, he then took 63 cards. So what he do, he took 63 different cards. He then took 63 cards and on each card he wrote down the properties of one element. So on each card, he took 63 card and on all the 63 card, different elements property he has written on each card. He sorted out the elements with similar properties and pinned the card together on the wall. He sorted out the elements with the similar properties. Means he found out, he searched which elements are there, which elements are having similar properties, and then he pinned them on with each other, and those which are not having similar property, they pinned them away of the each other. He observed that most of the elements got a place in the periodic table and were arranged in the order of their increasing atomic masses. So while doing it, while arranging these elements, he found out that each element can be arranged into the periodic table, and, and these elements could be arranged in their increasing order of their atomic mass. It was also observed that there occurs a periodic reoccurrence of elements with similar and physical chemical properties. So after certain number of elements, the next element comes if we increase the element into the increasing order of their atomic mass, the element after certain period comes which have the similar chemical and physical properties, and this is what it is known as the periodic reoccurrence of element. Periodic reoccurrence of element means after some period of elements, after some number of elements, there is a revision, there is a repetition of the physical and chemical properties of these elements which were present into the Mendeleev's periodic table. So this is how Mendeleev has created his own periodic table, which is known as the Mendeleev's periodic table. And all these 63 elements which were discovered at that time, they were all considered into the Mendeleev's periodic table on the basis of their formula of oxides and hydrides, and they were arranged in the increasing order of their atomic masses. Now, what were the achievements of the Mendeleev periodic table? That is what we want to study. So, what were the achievements of the Mendeleev periodic table? The first achievement, if we look at, we will realize that though Mendeleev arranged elements in the increasing order of their atomic masses on the basis of their chemical properties, he put cobalt before nickel, though atomic mass of cobalt is more than nickel. Now, this was the very good achievement that Mendeleev considered the chemical properties. He was not so rigid about arranging the elements into the increasing order of their atomic mass. Actually, the atomic, he put cobalt before nickel. Cobalt has got higher atomic mass than nickel, but still cobalt was not fixing into the group of elements which are similar, and that is why our Mendeleev put cobalt before the nickel, though it has got the higher atomic mass, and this was the wonderful thing he has done while arranging the elements into his periodic table. Later on, we came to know that yes, nickel, the arrangement of Mendeleev, uh, where cobalt is placed before nickel was the correct arrangement, and it has led to a proper arrangement of the elements into the periodic table. So Mendeleev did this right thing, even he was not aware about so many things at that time, or he has not having all the technologies which is available at nowadays. Mendeleev left some gaps in his periodic table. Mendeleev has left some gaps in his periodic table. Instead of looking up these gaps as a defects, Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. Now, what happens when Mendeleev were arranging the elements into the increasing order of the atomic masses? There were some atomic masses which was not available, which was not present at that time. So Mendeleev has to put some gaps, because on every box, or because on every box of atomic mass there was not element present. So he left some gaps into the periodic table, and he boldly predicted that if there is a new element uh, discovered instead of this gap, this element will have the similar chemical and physical property like the other element. This is how he predicted the properties of those not discovered element, and he said that surely these elements are going to be discovered. Mandeleev named this element by prefixing a Sanskrit numeral eka, that is 1, to these elements which he left the gap. So the name of preceding element in the same group. So if there is a gap in a particular group, then he put the name into the into the part where his his uh, where the next element, just before the next element, he put the word eka before it, and then the word eka is put before the element present or preceding element in the same group. So now when it comes to the element, this element has got eka word before it. This eka word actually he has given for the scandium, gallium, and germanium. Just to meet my dear students, I have called to receive. Huh. So Mendeleev actually gave the various names to the different elements. For instance, he gave scandium, gallium, and germanium, discovered later, have the properties similar to eka boron. So for scandium, he has given the name eka boron. Please remember, my dear students, that for scandium, he has given the name eka boron. For gallium, he has given the name eka aluminium. For germanium, he has given the name eka silicon. So these elements, which was for scandium, he has left the gap. For gallium, he has left the gap. For germanium, he has left the gaps. These gaps, when they are left for a particular element, these gaps were were uh, were given the names, like the gap which was given the name eka boron. Later on, the new element discovered, which was scandium. The gallium, which was given the gap name eka aluminium. Later on, gallium is discovered for that. The gap which was given the name eka silicon. Germanium is the new name, or germanium is the new element which was discovered for the gap. And then the properties of eka aluminium predicted by Mendeleev, and those of the other element gallium, which was discovered later, replaced eka aluminium. So the way our scientist Mendeleev has predicted the properties, for example, the property of eka aluminium, Mendeleev, the way he has predicted, the property of gallium was found very similar to that property which our Mendeleev has predicted. So Mendeleev boldly predicted these element, and Mendeleev boldly predicted, he he put some gaps. These gaps were given some names. Later on, the names of these elements have been, or later on, the new elements were discovered in place of these elements, and these elements which were discovered later, they were having the same properties as the properties which was uh, as the property which was predicted by Mandeleev, and they were having the same properties as the properties discovered by Mandeleev. Now, my dear students, this provided convincing evidence for both the correctness and the usefulness of Mandeleev's periodic table. So this was the very great thing about Mandeleev's periodic table, that he was arranging the element in a very correct order, and all the scientists at that time have been convinced, because the arrangement of Mandeleev's, or even the gaps that he put, were found to have the similar property element discovered at that time. Same way, there is one more very important achievement of Mandeleev's periodic table, is that noble gases like helium, neon, and argon, when these gases were discovered, they could be placed in a new group without disturbing the existing order of Mendeleev periodic table. So, my dear students, these noble gases like helium, neon, argon, these gases were discovered later, but they were placed in the Mendeleev periodic table without disturbing the Mendeleev periodic table. So, the way Mendeleev periodic table was arranged, there was no disturbance found into that arrangement of the Mendeleev periodic table. It was the extraordinary success of Mendeleev's periodic table prediction that led chemists not only to accept his periodic table, but also recognize Mendeleev as the originator of the concept concept on the base of which is he he was considered as the originator of the concept of the classification of the elements. So this is how, my dear students, we understood the various important achievements of the Mendeleev periodic table. Now we have the next question. Give the examples of noble gases and why they were discovered later. So the answer is very simple, my dear students, that helium, neon, argon, etc. are the examples of noble gases, and these gases were discovered very late because they are very inert and present in extremely low concentration in our atmosphere. So they are very inert and they are present in a very low concentration into our atmosphere, and that is why they are found, or they are discovered later, as far as these things are, as far as the discovery of this gas is concerned. Now, my dear students, we have the next one, which is known as the limitations of the Mendeleev periodic table. What was the problem? What was the incorrectness of the, or what were the limitations of the Mendeleev periodic table? No fixed position can be given to the hydrogen in the periodic table. So Mendeleev periodic table even did not have the position of hydrogen fixed. This was the first limitations of the Mendeleev periodic table. Now what is the second limitations of the Mendeleev periodic table? That isotope of an element have similar chemical properties but different atomic masses. Isotope of same element get a different position in Mendeleev's periodic table. This was the second limitation of Mendeleev's periodic table. My dear students, we know that isotopes of same element have different atomic masses. So if we put the isotope of the same element into the Mendeleev periodic table, this isotope will get the different position, and that is why the position of isotope cannot be placed, or the position of isotope was not same as the position of that particular element, and thus the position of isotope have got the another position into the Mendeleev's periodic table. The second important part is that the position of the hydrogen is fixed, was not fixed into the Mendeleev's periodic table. Now, my dear students, we want to study why the position of hydrogen was not fixed into the Mendeleev's periodic table. That is what it says, that give reason why the position of hydrogen is not fixed into the Mendeleev's periodic table. Let us see why the position of hydrogen was not fixed. Electronic configuration of hydrogen resembles that of the alkali metals, like alkali metals hydrogen combines with the halogen, oxygen and sulfur to form compounds having similar formula as shown in the examples here. Same way, my dear students, uh, one, one on the other hand, just like the halogens, hydrogen also exists as a diatomic molecules and it combines with the metals and non-metals to form the covalent bonds. So if we really look at the electronic configuration of hydrogen, it is 1. If you look at the sodium, it is 281, and if you look at the lithium, it is 21. So the number of valence electron of hydrogen is similar to the metals which are known as the alkali metals. And if we look at the compound, hydrogen is diatomic as well. Cl2 and Br2 and F2 are also diatomic. Hydrogen makes the similar compound as these halogens also make, and these alkali metals also make the similar compound like hydrogen. For example, HCl is the compound of hydrogen with chlorine and NaCl is the compound of sodium with chlorine. This is how our hydrogen resembles with both the alkali metals and halogen, and that is why the hydrogen cannot be given a fixed position into the periodic table. This is how, my dear students, we understand that the position of hydrogen was not fixed into the uh, periodic table. Now, what was the Henry Moseley's work? So, Henry Moseley showed that atomic number of an element is more fundamental property than atomic mass. On the basis of this, we have derived the modern periodic law. Please learn this, it is very important. Properties of elements are the periodic function of their atomic numbers, and there was a Mandeleev periodic law which was saying that properties of elements are the periodic function of their atomic masses. There is only two changes. Once we have in modern periodic table, we have the word atomic number, but in Mandeleev's periodic table, the word atomic masses. This is due to the Moseley's work, that Moseley have showed that atomic number is more fundamental property than the atomic mass. I hope, my dear students, you have enjoyed the classes. If you have doubt, you can ask. Dear students, बच्चों आप मुझे सुन पा रहे हैं? Please learn these two laws which are known as the modern periodic law and Mendeleev periodic law. I am going to repeat them once again for you.